Fontanins' theory of agricultural locations and its modifications.
Johann Heinrich von Thunen, 1783 to 1850, was a German economist of great originality who contributed highly significant concepts and techniques to economic theory. He was the first to develop an exact definition of marginal productivity in the modern sense, although he did not use the term, and to apply the principle generally in the theory of production and distribution. He was a founder of mathematical economics and of econometrics, combining systematic empirical research with a genius for abstract reasoning and generalization. Most of his economic theory is based upon models of general static equilibrium, often expressed in terms of systems of equations, but he also contributed to the theory of capital formation and economic growth. Other areas in which he pioneered include theories of economic location, rent, and enterprise profit, and some of the more practical aspects of agricultural economics. He emphasized far more than did his English contemporaries the central economic problem of allocating scarce resources so as to maximize the achievement of defined goals. In this lesson, let us explore the importance of von Thunen's theories and its implications from the following headings. Von Thunen's regional land use model, urban land market theory, wages, interest and marginal analysis, weaknesses and criticism, relevance of von Thunen model.
Fontanins' regional land use model. If modern economics began with Adam Smith, modern location economics began with Fontanin, 1826. He was the first to develop a basic analytical model of the relationships between markets, production, and distance. For this purpose, he looked upon the agricultural landscape. The relative costs of transporting different agricultural commodities to the central market determined the agricultural land use around a city. The most productive activities will thus compete for the closest land to the market, and activities not productive enough will locate further away. The model has a set of basic assumptions which reflects agricultural conditions around a city in the early 19th century. Isolation. There is one isolated market in an isolated state having no interactions or trade with the outside. Ubiquitous land characteristics. The land surrounding the market is entirely flat and its fertility uniform. Transportation. It is assumed there are no transport infrastructures such as roads or rivers, and that farmers are transporting their production to the market using horses and carts. Transportation costs are dependent of the type of commodity being transported to the market as well as the distance involved. The model compares the relationships between production cost, the market price, and the transport cost of an agricultural commodity and is expressed as follows. R is equal to Y into P minus C minus Y FM, where R is the rent per unit of land, Y is yield per unit of land, P is market price per unit of yield, C is average production costs per unit of yield. M is distance from market in kilometers or miles. F is freight rate per unit of yield and unit of distance. All agricultural land uses are maximizing their productivity or rent, which in this case is dependent upon their location from the market or central city. The role of farmer is to maximize his profit, which is simply the market price minus the transport and production costs. The most productive activities, gardening or milk production, or activities having high transport costs, which is firewood, locate nearby the market. The above figure provides an overview of Fontanins' agricultural land use model with the basic assumptions being applied: isolation, ubiquity, transportation. It can be divided in two parts. The pure isolated state over an isotropic plane or left. In this case, the model takes a shape of perfect concentric circles. The potential impacts of modified transport costs, a navigable river, and the presence of a competing center, right. The relationships between agricultural land use and market distance are very difficult to establish in the contemporary context. However, a strong relationship between the transport system and regional agricultural land use patterns can be acknowledged at the continental level in North America. Urban land market theory. In the years that followed Fontanins' seminal approach to a theory of land use, several attempts were made at analyzing various components of the urban and regional system. See, for example, Romano's 1976. However, it was only after almost 140 years that W. Alonso would present his celebrated urban land market theory that applied and refined Fontanins' original ideas. Alonso, 1964. This theory aims to describe and explain the residential location behavior of individual households and the resulting spatial structure of an urban area. The focus is on residential location. The behavior of firms is treated more briefly and abstractly. The central concept of this theory is a bid-rent function for each householder and/or firm. The bid rent of a household is defined as the maximum rent that can be paid for a unit of land, example, per acre, some distance from the city center if the household is to maintain a given level of utility. Hoover and Giaratini, 1984. The bid rent curve R of the actual land rents in the city reflects the outcome of a bidding process by which land is allocated to competing uses. Residential demanded by households and commercial, industrial demanded by firms. As in Fontanins' theory, a monocentric, flat, continuous and uniform urban area is assumed. The city center is the central business district, CBD, where households work and shop. A household's utility or satisfaction is assumed to depend on housing of a given lot size, distance from the city center, reflected in the transportation cost, and all other goods, Chapin and Kaiser, 1979, Romano's, 1976. The household allocates its fixed budget among these three components with the aim to maximize its utility. Its preferences determine the trade-offs it is willing to make among the above three items. The price of housing and of other goods is independent of the quantities purchased. The price of housing and of commuting depend on distance from the city center. There is a distance decay relationship between land rent and distance from the CBD. The further a household lives from the city center, the more it will have to spend on commuting and the less it will be able to spend on housing. Based on these assumptions, the bid rent curves are downward sloping. That is, rent decreases with distance from the city center to offset transport costs, and single valued, that is, for a given distance from the CBD, only one rent bid is associated with a given level of utility. The steepness of the slope of the bid-rent curve depends on transport costs and the household's or the firm's demand for space. Steeper curves are associated with higher transport costs and or less demand for space, hence higher value attached to accessibility. Flatter curves are associated with lower transport costs and or higher demand for space, that is, hence preference for more outlying locations. Finally, lower bid-rent curves are associated with greater utility as, assuming fixed budgets at any given distance from the CBD, if a lower rent bid is accepted, more goods can be consumed. Hoover and Giaratini, 1984, page 154. Wages, interest, and marginal analysis. Fontanins' application of marginal analysis to the theories of wages, interest, and resource allocation. The most important of his contributions to economic theory appears in Volume 2 of Der Solariat State and was worked out during the period 1826 to 1848. He used a number of mutually corroborating approaches to the problem with verbal, numerical, and algebraic modes of expression. A few brief examples follow. Using his model of the isolated state, he assumed free, homogeneous, mobile laborers who receive wages in excess of minimum subsistence and who are capable of producing products either for current consumption or for capital formation. In his analysis of capital formation, essentially independent of the capitalist-laborer relationship, the workers either accumulate the excess of their wages over subsistence until they can devote a year's labor to capital formation while living on their accumulated stocks, or they form groups of workers, some of which produce capital while the rest simultaneously produce subsistence for the entire group, all members then sharing equally in the ownership of the new capital. Fontanins demonstrated that in competitive equilibrium, the interest per unit of capital equals the increment of product value resulting from an increment of capital, all other inputs remaining constant. The same principle is then applied to labor. Both labor and capital are shown to be subject to diminishing incremental returns, but the marginal product of labor increases as the quantity of capital per worker increases. Fontanins emphasized the importance of using infinitesimal increments in the formal analysis. He also pointed out that the natural rates of wages and interest prevail only under conditions of ideal competition and resource mobility that unfortunately do not prevail in the real world. He demonstrated by verbal and algebraic statement and by numerous examples the principles of cost minimization, Marshall's principle of substitution, and net revenue maximization with emphatic assertions of their general applicability and their fundamental economic importance. Productive agents can be substituted for one another, and an optimum is reached when the ratio of their respective marginal products equals the ratio of their respective unit costs. Net revenue is maximized when the value product of the last added unit of each agent just equals its costs. The natural wage indicated by the formula root AP, in which A equals the value of the product of labor and capital and P equals the subsistence of the laborer and their family. The idea he presented is that a surplus will arise on the earlier units of an investment of their capital or labor But as time goes on, the diminishing return of newer investments will mean that if wages vary with the level of productivity, those that are early will receive a greater reward for their labor and capital. But if wage rates were determined using this formula, thus giving labor a share that will vary as the square root of the joint product of the two factors A and P. This formula was so important to him that it was a dying wish of his that it be placed on his tombstone. Weaknesses and criticism. The model was developed in an isolated state and did not take into consideration differences in sites or local physical conditions. It can be modified by relaxing some of the conditions set forth by Fontanins. Differential transportation costs. Example, boats are the cheapest mode of transportation. Variations in topography. Soil fertility. Changes in demand or price of the commodity. However, the model tends to hold true in most instances. The theory may break down somewhat in industrial and post-industrial economies as urban expansion or sprawl occur. For example, modern refrigerators enable perishable products to be transported longer distances. The theory generalizes that there is one mode of transport, which is the board. Like many other models in geography, Fontanins' model was criticized frequently due to its restrictive nature. The basic conditions of the model, however, could be approximated by slight modifications of the respective reality. The circular pattern, which can be attributed to only one market and excluding transport costs, gradients running from the center, is, for example, only one of the many conceivable geometrical starting situations. If other natural landscapes or transportation routes are present, the land use zones would be stripe-formed. If several markets were present, groups of zones would be formed around each market. A justified objection against it is a reference to the absence of any productive profit. In Fontanins' theory, different agricultural uses compete for the optimal location, which results from the product-specific supply or expenditure relation. The competitive power becomes indirectly measurable over locational rent. After deducting production costs and location-specific transport costs, however, nothing more remains of the market profits. The Fontanins model leads to the idea of complete self-sufficiency among farmers. Thunen'S idea of economic rent attempted, while ignoring other characteristics, to explain the use of zones controlled solely by economically rational perception. Possible consumers play, finally, the crucial role for the choice of location. At the same time, evaluation of all potential locations is released, which leads to a zoning of the possible offers. This simply developed space restaurant model reacts, however, sensitively to changes of the space overcoming costs. It possesses, however, due to its universality, nevertheless, a high value within geographical questions and methodology. It has now become obsolete due to the fact that he never predicted the revolutionary technology we have today. Some of the points raised by scholars regarding this theory are as follows. The conditions described in this model, that is, in an isolated state, are hardly available in any region of the world. There are internal variations in climatic and soil conditions. The Fontanins' assumptions that there are no spatial variations in soil types and climates are rare. It is not necessary that all types of farming systems, as described by Fontanins in his theory, exists in all the regions. In many European countries, location of types of farming in relation to market are no longer in existence. The Thunen'S measures of economic rent and intensity are difficult to test because of their complexity. The measurement of number of man days worked in a year, cost of labor per hectare, or cost of total inputs per hectare is not uniform in intensive and extensive types of farming. Similar is the case with the measures of intensity. Fontanin himself has admitted that with a change in location or transportation or market center, the pattern of land use will also change. Environmental variables, as pointed out in connection with the physical limits model, are only a general locational constraint and play a passive role in shaping the distribution of modern commercial agriculture. In the human technological context, the employment of artificial irrigation, chemical fertilizers, and the like allows farmers to overcome most environmental barriers. Three kinds of economic empirical irregularities can be anticipated to influence the national Thunenian pattern: transportation biases, distant concentrations of production that appear inconsistent with his model, and secondary markets. The Thunenian model was developed in the early 19th century. Since then, conditions have entirely been changed. Therefore, but this model is still considered to be significant in many ways. Relevance of Fontanin model. The Fontanin logical framework has been important in the evolution of our thinking of how land values and land uses came about in the modern city. Indeed, Fontanin's general theory of land values and land uses has been important in the evolution of thought. Fontanin was one of the first to adopt the new maths of his era, calculus, and to apply that mathematics to a problem of social sciences. He was a pioneer in the use of data for the verification of his normative theory. Fontanin's innovative research method was similar in composition to what we would today call computer simulation. Indeed, much of the approach to social science thought today can be traced back to Fontanin's general method of analysis as its precursor. His contribution to modern thinking in the social sciences stands unparalleled. His general approach became diffused through its adoption by the leading scholars of the generations that followed him and by their adoption of his general method in their own work. Fontanin's application of his general method to his own land use theory became generally accessible only in the early 1950s when Edgar S. Dunn published his interpretation in English. Fontanin is no exception among the greats whose reasoning in time is recognized to have contained an error. The beauty of using mathematics over mere verbalization to express concepts or hypotheses is that when an error is made, it can often be corrected irrefutably. Dunn found an error in Fontanin's treatise and corrected it. It can be recalled from the discussion above that a caveat was to be presented to Fontanin's general theory. Once the hierarchical ranking of farming systems was established, such as that listed in Table 14.1, those of lower ranking would always be outbid by those of higher ranking should both happen to be competing for the same land. Instead, Dunn correctly reasoned that since locational rent changed by a different amount of each agricultural product with distance from the central market, then at some locations a lower ranking farming system could indeed outbid a higher ranking farming system, even though positive rents were bid by the higher ranking farming system. All over the world, scholars have tested and applied the Fontanin's theory of agricultural location. The greatest importance of the theory lies in this fact that it has given a new direction of thinking, resulting into the modified way of its application. Some researchers have used Fontanins' model as a general framework for interpreting the spatial framework of the economy. Others have worked on a more direct basis. Thus, Fontanins' model has been applied to the distribution of European agriculture in 1925. Regarding application of Thunenian model in developing countries, M. H. Hussain, 2010, has observed that in many of the underdeveloped and developing countries of the world, in both the villages and towns, cropping belts are found. In the villages of the Great Plains of India, similar patterns can be observed. The consolidation of holdings in India has also modified the crop intensity rings, as each of the farmers is interested in growing the commodities for his family consumption, as well as some marketable crops for earning cash to clear his arrears of land revenue and irrigation charges, and to purchase the articles from the market for his family consumption. In some of the developing countries like India, Pakistan, and Mexico, the introduction of HYV or high yielding variety has disturbed the application of Fontanin model. The fast development of means of transport has made it possible to transport the perishable goods at long distances in short period of time. Thus, the model advocated by Fontanin is no longer operative in its original form.
Thunen'S model was created before industrialization. Even though it was created in a time before factories, highways, and even railroads, it is still an important model in geography. The Thunen model is an excellent illustration of the balance between land cost and transportation costs. As one gets closer to a city, the price of land increases. The farmers of isolated state balance the cost of transportation, land and profit and produce the most cost-effective product for market. Of course, in the real world, things don't happen as they would in model. He expressed his hypothesis using clear and unambiguous mathematics. He reasoned that by placing reasonable numerical values into his mathematical formulation, he could closely predict actual land values and land uses. Among the general conclusions were that land values decline with increasing distance from the market center, and the land values and land uses change as the various costs of production, transportation, and prices of agricultural commodities change.